Good afternoon, everyone. My name is Maya Luria with TMC for Seniors, and we're continuing on with our discussion in January about the innovations in healthy aging. And today I've got Dr. Jennifer Stern with me here. She is a PhD with the University of Arizona College of Medicine. She joined the faculty over at the U of A College of Medicine in the fall of 2018, and she serves as the assistant professor in the Division of Endocrinology, Diabetes, and Metabolism, with joint appointments in the Department of Physiology and Bio 15 Institute. Wow, Jennifer, that's you've got a lot on your plate. Today, she is here to share with us what she's learned through her research on diabetes. So we're so happy to have you here. This is a topic that is something that comes up all the time over here at TMC for Seniors because we do offer quite a bit of diabetes education. So we're so happy to have you here today, Jennifer. Thank you. Welcome.
Well, thank you. Thank you, Maya, for that kind introduction and for the opportunity to share with everybody some of the research that we're working on and other experts in the aging field are working on as well. So my lab at the U of A is focused on understanding the metabolic impact of various interventions that promote healthy aging. So lifespan is increasing, and that's evident here. You can see in these lifespan curves, if you compare 1871 to about a decade ago, 2011, mean lifespan is increasing pretty drastically. And it's estimated that in another decade, lifespan will increase even further. And that's primarily and thanks to improvements in healthcare, technology within medicine and science. But unfortunately, health span is decreasing. And what I mean when I talk about health span is a high quality of life throughout our lives, mainly free of disease. And one of the most prevalent age-related diseases is type 2 diabetes, and it goes really hand in hand with obesity. And you can see here, these are CDC maps that are illustrating the rise in the prevalence in type 2 diabetes between 1994 and 2014. So during that time span, you can see that these maps become darker red and orange, indicating an increased prevalence in type 2 diabetes. And if we were to look at similar maps showing the prevalence of obesity, they would look nearly identical. Now, my lab is mostly concerned about type 2 diabetes because it is, in fact, most prevalent in the aging population in people 65 years and older. And you can see males and females equally have an increased prevalence with age, such that by the time 65 to approximately 80 years old is reached, more than 20% of individuals will have type 2 diabetes. So we're all going to age. That's a given, that's simple math. But the challenge is, how can we slow aging? Well, calorie restriction without malnutrition is the one tried and true non-genetic intervention that consistently increases not only lifespan, but it also improves health span in a wide range of animals and species, from worms, flies, to mice, all the way to non-human primates. And this graph here on the left is showing data from a study in rhesus macaques, where a group of scientists at the University of Wisconsin put these animals on a calorie-restricted diet. And they showed that compared to the control animals here that were fed ad libitum, and by ad libitum, I mean they were able to eat freely throughout the day, those monkeys that were calorie restricted, you can see there was a much greater percentage of animals without age-related disease. Now, what I really like about this study is that these scientists also showed us pictures of these animals. So you can forget everything I just said and ignore this boring graph on the left and just take a look at how these animals appear. This animal here on the left in A and B, this is a monkey that was fed ad libitum throughout life. You can see his posture is quite hunched. He's losing quite a lot of hair. He has some skin irritation here. We call that dermatitis. And in comparison, if you look at the monkey here on the right in C and D, he's got a nice, full, shiny coat of hair. His posture looks excellent. His body condition looks great. His eyes are nice and bright. He looks excellent. Now, I've shown this picture previously in a talk I gave to my department, and one of my colleagues said, well, yeah, but that calorie-restricted monkey on the right looks really ticked off. So he's pretty healthy, but he also might be a little hangry. But nonetheless, it's pretty obvious that calorie restriction in this study really improved the health of these animals. You can see that both quantitatively in this graph on the left, and then also just by looking at these animals. Now, studies in mice have shown very similar results. This is now looking at lifespan in a study that was performed back in the 1980s, again, out of Rich Weinreich and Raj Sohal's lab at the University of Wisconsin. And they showed that compared to mice fed an ad libitum diet, that's these purple dots here, again, they were allowed to eat freely throughout the day. Those mice fed 25, 55, and even a 60% restricted diet show a really nice increase in lifespan. And lifespan tends to increase as the level of restriction increases. Now, the concept of calorie restriction affecting aging and health really is nothing new. In fact, one of the first studies published investigating the impact of calorie restriction on aging came out almost 100 years ago in 1935. And you can see here Clive McKay in this study calorie restricted mice and showed again a really nice increase in lifespan. That's these squares and triangles compared to the circle line. Now, what's interesting about this study is he actually set out to investigate the impact of calorie restriction on cancer progression. And what he found is that these animals also lived longer. Now, if you fast forward to present day, the concept of fasting, calorie restriction, intermittent fasting, call it what you might, has really seeped into popular culture. This was the cover of Food and Wine magazine a few years ago. They had a whole feature on eating smarter to live longer. And if you walk into any bookstore, or nowadays more likely go on to Amazon.com, you're guaranteed to find hundreds of books on intermittent fasting, calorie restriction, and aging. So this is really quite a hot topic now in popular culture. Now, we study mice as a model for human aging, but our goal is to translate these findings to humans and to improve aging and health span in people. And so before I go into some of the studies that we're working on in my lab, I first want to make a few comparisons between mice and humans. I don't think any scientist out there that studies mice will claim that mice are just tiny humans. They have a lot of differences, but they're an excellent model for studying human aging. And phases of life in the mouse have been pretty well studied such that we can make those comparisons. So mature adult in a mouse is between 3 and 6 months of age, and that would be comparable to a 20 to 30-year-old human. And a middle-aged mouse is between 10 and approximately 14, 15 months of age. That would be comparable to maybe a 40 to about 50-year-old human. And then an older aged mouse would range from 18 to maybe 26, 27 months of age would be really advanced age. And that would be comparable to approximately a 56 to 80-year-old human. So in my lab, we're studying right now 2 interventions to improve aging and enhance health span. One is calorie restriction, and I've talked a little bit about caloric restriction already. And second is exercise, and we use voluntary wheel running in the mouse to induce an exercise intervention that would be most similar to what a human might do as a lifestyle change. And some of the data that I'm going to show you in our calorie restriction studies is much different from most of what's in the literature. We've been using a 15% restriction in our animals. And I've depicted here on this dinner plate what a 15% restriction might look like. It's really quite moderate compared to the 40, 50% restriction in some of the animal studies. So before we calorie restrict or allow our animals to exercise, we first just wanted to look at what happens in an aging mouse with basic metabolic and physical function parameters. So first we looked at body weight, and we found that similar to humans, as mice age, we see an increase in body mass from young adulthood to middle age, and this is maintained throughout older age. Once these animals go into advanced age, or 29 months, we see that body weight starts to decline. And body composition follows that pattern. So just like humans, as mice progress into middle age, we see an increase in fat mass. And as they go into more advanced age, we see a decrease in fat mass. And by 29 months of age, you can see that fat mass is even lower than that in a young animal. So this is more of a model of frailty once we get to that advanced age in the mouse. Now, we use several measures of physical function in our mice that are actually very similar to what researchers who are performing human studies use. One of those measures is called grip strength, and it's exactly what it sounds like. So as depicted in this cartoon, an animal grabs onto a piece of wire that's connected to a force transducer, and we can measure how strong that grip is on that piece of wire. Very similar to what happens in humans, grip strength decreases with age in the mouse. And we also can study balance and coordination in these animals and measure how long they're able to stay on a rod that's rotating slowly and gradually increases with speed. And what we found, similar to grip strength, is that balance and coordination tends to decrease with age in the mouse. So coming back to that 15% restriction that I mentioned, we were really happy to find that this modest level of restriction, just cutting calories by 15%, improved the amount of time that they were able to stay on that rotating rod, and it also improved grip strength. And these are in pretty advanced age mice, 24 and 27 months of age. And we also found the metabolic function improved with calorie restriction in our aged mice. So in 10-month-old mice and in 18-month-old mice, we found that serum glucose decreased. That's our blood sugar that when you go to the doctor, they check every year to determine if you might be pre-diabetic or have an impairment in glucose homeostasis. Serum triglycerides also decreased in the middle-aged and older mice, though not in our advanced age animals. And similarly, fat mass and circulating fat decreased. We also found that fat in the liver decreased in our aged mice in response to this moderate calorie restriction. And this increase in fat in the liver is one major factor that predisposes us to the development of type 2 diabetes. So we were pretty excited to find these results. Now, I want to share with you one piece of study design that's important when considering the results of our study. And that is that our ad libitum fed mice, they were able to feed freely throughout the day. Our calorie restricted mice were fed once a day at the beginning of the dark cycle. So when the sun goes down, the lights go out. Mice are nocturnal. That's when they do all of their eating, socializing, running around activity. And so we fed them at the beginning of the period of day when they would normally be eating. So they were essentially fasting for the rest of the day. Now, a paper just came out last October, which tested the hypothesis, maybe it's just fasting and not necessarily a reduction of calories that drives these metabolic and geroprotective effects of calorie restriction in mice. By geroprotective, I simply mean that it's protecting us from those age-related disease. And so they did this really neat study where they had ad libitum fed mice, just like we have. They had a time-restricted group where they had unlimited food access for only 3 hours per day, and the remaining 21 hours they had no food access. And then they had a restriction group where they were fed once a day, similar to our study, only this was a 30% reduction. And what they found is that it wasn't the calorie restriction, but it was the fasting that's most likely responsible for the metabolic and age protective benefits of a calorie restricted diet. Now, this study was performed in mice, but it definitely warrants future studies in human cohorts looking at the effects of prolonged fasting periods on metabolic function and overall health span. Now, what about studies using calorie restriction in humans? Well, as you can imagine, it's pretty challenging to put together a large clinical trial where you ask people who can usually eat whatever they want, whenever they want, to restrict their calories. But one group of scientists out of Duke University, in collaboration with the National Institute of Science, National Institute on Aging, put together a really remarkable clinical trial. They took several hundred individuals and asked them to restrict their calories by 25% for 2 years. Now, as you might guess, they didn't achieve that 25% restriction. But what's neat about this is that even though overall most people in the trial only restricted their calories by 12%, so that's very similar to our 15% in the mouse, they found multiple benefits, particularly in cardiometabolic risk factors. So this is just a little sampling of some of the results that they found, but this very small level of calorie restriction decreased LDL cholesterol, so that's our bad cholesterol. It decreased blood pressure, both systolic and diastolic, and it improved insulin sensitivity. So the conclusion that these authors noted is that 2 years of moderate calorie restriction, and I want to emphasize that moderate, significantly reduced multiple cardiometabolic risk factors in young non-obese adults. So these are really exciting findings, giving us some insight as to the aging and metabolic benefits of a small level of calorie restriction. So a little bit might just go a long way. Now I want to move on and talk a little bit about our exercise intervention. So as I mentioned, we use voluntary wheel running in our mice to examine the effects of initiating an exercise training late in life on aging and metabolic function in mice. Now, these studies came from our idea based on previous studies in humans showing that approximately 150 minutes of vigorous physical activity improves survival and decreases age-related disease. And this is an example of one such study. You can see that compared to the inactive men, that's this blue dotted line, the active individuals lived longer. And they also had a decrease in metabolic disease. Now, in fact, if we look at a study that came out about 2 decades ago in the New England Journal of Medicine, where they compared the incidence of type 2 diabetes in a placebo group, a group that was given metformin, which is one of the most highly prescribed diabetes medication on the market, and the lifestyle intervention, which included that 150 minutes of vigorous physical activity per week, you can see that physical activity was even more effective in decreasing the incidence of diabetes than metformin. So you could exercise as opposed to taking a drug and have an even better outcome. It's a pretty remarkable study. Now, I want to introduce you to Hiromu Inada. This is all goes in credit to my graduate student, Tyler Marks, who did all of our exercise studies. He just completed his master's degree in May and will be moving on to medical school next year. But he did some research and found that this gentleman, the world's oldest Ironman, who competed in an Ironman competition at age 85, didn't start training until he was 69 years old. And Tyler makes the joke, well, I've never done an Ironman, but I just think I'll wait until I'm 85 to do that. But this brings me to a statement in the National Institute on Aging pamphlet on how to start an exercise program late in life. And the message is, don't worry if you're not exercising or currently active, or if you've never exercised, or if you were before but now you've stopped. It's never too late to get moving. So based on that sentiment, we wanted to understand what the metabolic effects of initiating exercise late in life are. So a lot of those studies showing that 150 minutes of vigorous physical activity decreases age-related disease and increases lifespan. A lot of that data comes from people who are lifelong exercisers. So we wanted to see what are the metabolic effects if you are similar to the Ironman competing at 85 years of age. And so we perform studies in mice that have free access to a running wheel. We don't force them to run. It's just part of their cage. And we can quantify how much they run throughout the day, and then perform studies, again, investigating the effects on physical function, metabolic function, and the expression of genes and proteins that we know to regulate aging. So what we first noticed is that, again, mice sleep throughout the day. This is as we would expect. So between 7 a.m. and 7 p.m., when the lights are on, they're not doing much. The second those lights go on, though, you can see both the young and the aged mice start to get on their wheel and exercise. And what we found to be really interesting is that, yes, the young mice, you can see here in the black, they exercise on their running wheel quite a bit more than the aged mice. But they kind of poop out maybe 4 hours in and really start to decline. And so a joke in the lab is, well, the aged mice, they're just more reasonable. They're just, they're thinking ahead. And then so they're kind of going slow, but they maintain that low level of exercise pretty much throughout the entire dark cycle. And by the end of the nighttime, you can see they're actually running even more than the young mice. So we were really happy to find thus far, these studies are still in progress, but what we found so far is that initiating an exercise program or voluntary wheel running late in life in the mouse improves insulin sensitivity. It decreases fat mass and it decreases liver fat. Again, that's something that will predispose us to developing type 2 diabetes in the future. Now, at about 10 minutes to 2 o'clock, Maya called me and she's like, "Where are you?" And I said, "Oh, I'm sorry I haven't gotten online yet. I was just adding a study that I just found online. It was just published yesterday. So this is hot off the press. And I think the conclusion really speaks to what I've been trying to convey to everybody, and what I think the aging field is really focusing on. And that is that even a low level of physical activity can prevent death and improve aging. And so this group of scientists put an accelerometer on individuals. These were people from the NHANES study. And they did two things. They looked at the association of physical activity and mortality in a large group of samples, people from the United States. And second, they wanted to estimate the number of deaths that were prevented annually with what they call a modest increase in moderate to vigorous physical activity. They call that MVPA. And they concluded their study by saying that they estimate approximately 110,000 deaths per year could be prevented if people in the US between the ages of 40 and 85 increase their MVPA, that's that moderate to vigorous activity, by only a small amount. And 10 minutes a day is what they estimated based on this population study. So again, similar to calorie restriction, it appears that physical activity a little goes a long way. So it's never too late to get moving, and you don't have to be like the 85-year-old Ironman. If you can just exercise a few minutes a day, you can improve your health span and lifespan. So before I conclude, I just want to give everybody some sources from the National Institute on Aging. There's some great recommendations on how to start an exercise program, some tips for healthy eating, and that's here in these links down below. I think Maya said she was going to give everyone the slides, so feel free to visit those sites. And I'd be happy to take any questions, but first I want to acknowledge everyone in my lab who did all the hard work in some of the studies that I shared data from. Where Marks is my master's student who did all of the exercise studies. Susma, Emily, Kai, Luke, India, another Emily, and Anna all helped tremendously with all of our calorie restriction studies and the exercise studies. And if you'd like to learn more about our research, you can visit our website. I've posted that here, or you can follow us on Twitter. So with that, I'd like to thank everybody for your attention, and I'm happy to take any questions.
Thanks so much, Jennifer. So I have a couple of questions. One is about, is fasting a good option for everyone, or are there factors that could make this not a good option for someone?
Absolutely. Yeah. And that's something that you would want to talk to your doctor or your dietitian about before you start on any fasting regimen, especially if you have type 1 diabetes and you're using insulin. That's something that you want to be really careful with. Almost any medical condition I can imagine that would be affected by long-term fasting. So this is more information to keep in mind when you're looking at, new things that come out in the news, or, on your Google feed, but you definitely want to consult with your doctor or dietitian before you
Of course, yeah.
try.
We actually we actually had a class all about intermittent fasting in December, and I know we've had some seniors that have started to try that as well. They've actually said, "Oh yeah, I started that intermittent fasting." So we've got some folks that are trying that out. Do you have any tips for managing stress while someone might be doing sort of that fasting? I know you mentioned the word hangry, and I know that often comes up when when somebody is hungry. Do you have any ideas for that? Is there something that you've discovered with the monkeys that were fasting, or?
Well, I think first of all, the timing of fasting can really affect just that. So, and I'm not familiar with the intricacies of the fasting regimens that are, currently being prescribed or that are in, some uh, informational books. But if you think about when you would normally eat dinner, um, maybe people eat dinner at 6 p.m. And then the goal is to, stop eating and not kind of snack throughout the night on a lot of these intermittent fasting protocols. So it's actually not impossible to have, say, a maybe 13, 14-hour fast. If you eat dinner at 6, you're done eating by 7, and then you wake up the next morning and you wait until maybe 9 o'clock to have breakfast. So, and I'm not prescribing this, I'm not a registered dietitian,
Of
but in
course.
that sense, really that protocol, if you will, really just prevents you from snacking throughout the night.
Okay, good. Yeah, that's it's good to always hear some different ideas about it, and it was fascinating just to sort of see, especially when you showed those pictures of the difference, from your research. So it really does show. Um, it's really fascinating to just learn all about that, and see what's being done out there, and what may happen down the road, as far as diabetes is concerned. So I want to thank you so much for being here today. We will go ahead and share your PowerPoint afterwards to anyone who registered for the program. And if somebody is interested, they can certainly give us a call over at 520-324-1960, and we'd be happy to share that with you as well. And Jennifer, thank you so much again for being here. We are wrapping up our programs for the month of January, and we will be back on in February for Love Your Heart Month. So we will see everyone then. Thank you again.
Thanks for having me.